is Mohammed. I'm going to be giving a brief history of refrigeration. All right. So these are some common methods that we've used throughout history for refrigeration. But first, the goal of refrigeration is actually to move heat from a low temperature source to a higher temperature source. And really the only way you can do that is by putting work into some system, because you can't freely move heat from a low temperature to a high temperature. You can only go freely from a high temperature to a low temperature. So, one of the easiest ways is just using natural ice, frozen water. It cools the area down. People used to have ice boxes where you get a giant brick of ice, you throw it in the box, throw in your perishables with it, and it would stay cool. Evaporative cooling is another method, and more recently we have vapor compression cycle. So evaporative cooling is also one of the oldest methods of refrigeration. It essentially uses the evaporation of water to cool air. And so the way that works is you have hot air coming in, and then you have, this is a evaporative cooler. You can use it for a house or basements or different kinds of RVs. You pump water up and down, and it drips down a membrane. And so then you have hot air blowing onto that membrane, and the evaporation of the water takes away heat energy from the air. So you're increasing the humidity of the air, but you're also decreasing the temperature of it. And then it gets blown out into the house or wherever you want it to be. This is the same way humans cool off, because when you sweat, you have water on the surface of your skin, and that evaporates into the air and takes the heat energy, and you feel cooler. And there's been evidence that this method has been used all the way back since ancient Egypt and Persia. It's really only effective in arid climates. Egypt, Persia, I think southwestern US, Texas, California, because it requires a low humidity to really be effective. In Louisiana, we don't really use it because humidity can hit triple digits here, and it's pretty much useless. So here is the refrigeration cycle, which is used in vapor compression refrigeration. You have your compressor up top, which takes a working fluid and compresses it to a high pressure vapor. It flows through a condenser where the heat is taken away from that working fluid, and it condenses into a liquid. Then it flows to the expansion valve where the pressure drops significantly and becomes a liquid and vapor mixture. You can see there in the PV table, we are down here. And so then it passes through the evaporator, where a fan will blow the warm air that you want to cool down over the evaporator, and that liquid and vapor mixture absorbs the heat and turns completely into a vapor, where it will then pass down, go back to the compressor, and the cycle starts all over again. This method was first described in 1805 by Oliver Evans. We consider him the grandfather of refrigeration. That's because he didn't really design or patent a system like this. He just sort of came up with the idea of the cycle. It wasn't until 1834 where Jacob Perkins actually built a system that worked, and he was able to patent it. And so that's why we consider him the father of refrigeration. Early systems used ether or ammonia as the working fluid, and these were either very flammable or very toxic. It wasn't really good if it leaked out or someone had to work on a system like this. We used CO2 later on. It was just a safer working fluid. But in the 1890s, we synthesized chlorofluorocarbons, and they were non-toxic and had very, very low flammability. But they really weren't used widespread until the 1930s, where actually General Motors started investing in the synthesis of more chlorofluorocarbons. And so that's what these CFCs have very useful properties. They have like very low vaporization temperatures, and they were more efficient when used in the vapor compression cycle. are some of the continued improvements we're constantly making. We are improving manufacturing methods, having tighter tolerances, better designs of heat exchangers and such, because the more efficient you can make your heat exchanger, the better your heat rejection and better heat absorption through your condenser and evaporator. Material quality has improved a lot since the 1800s, allowing us to use higher working pressures and temperatures, as well as various rubber seals, gaskets, even components in the motors that drive these systems. And also the development of new refrigerants, because CFCs are incredibly horrible to the environment. They will tear a hole in the ozone layer and also cause a massive greenhouse effect on the Earth. And they were eventually banned in the 1980s. So we're moving towards refrigerants that do less harm to the Earth, while also trying to maintain a very good efficiency and performance values. Yeah, that's it. Any questions?